Hello good day viewers, here is our second to the last problem. In this tutorial we are going to integrate this function 5x plus 1 divided by 2x squared plus 4x plus 3 with respect to x. One thing you should observe here is that if you differentiate the denominator, you're going to obtain 4x plus 4. So how can we transform our numerator in such a way it will contain 4x plus 4? That's our main goal. Our numerator is 5x plus 1, right? And I know I can write this as 5x plus 5. What have I added? I have just added 4 because this is 1 and this is 5. So to compensate, I'm going to subtract 4. 5 minus 4 is 1. So let me group the first two terms. We have 5 in common. So I can say that this is equal to 5 outside, inside I have x plus 1, right? Then I still have minus 4. Still, I want to transform it into 4x plus 4. So by multiplying these two times by 4, they will become 4x plus 4, right? So I have 5 multiplied by 4x plus 4, right? Then minus 4. I have multiplied by 4, therefore to compensate, I'm going to divide by 4, right? So divide the whole of this by 4. Now our original numerator has been transformed into a term that contains 4x plus 4. So let me replace our numerator with this. So therefore we have the integral of, I can now even write it as 5 over 4 multiplied by 4x plus 4, right? Then minus 4. Our denominator is still 2x squared plus 4x plus 3. 2x squared plus 4x plus 3 with respect to x. Now let us split this fraction because we have two terms here. So this is the same thing. I can bring 5 over 4 outside because it is a constant, multiplied by the integral of 4x plus 4, right? We divided by the whole of 2x squared plus 4x plus 3 with respect to x. Then I will take the other one, minus 4, right? Multiplied by the integral of 1, because I have just factored out 4, divided by 2x squared plus 4x plus 3 with respect to x. So this is what we have to integrate separately. Let me start with this one. Because if we differentiate this, we are going to obtain this. Therefore, the solution to this problem is just what? The natural log of what? The absolute value of our denominator. That is what you should remember from elementary calculus. Therefore, let me bring this one separately. We have 5 over 4 multiplied by the integral of 4x plus 4 divided by 2x squared plus 4x plus 3 with respect to x. I told you this is the same thing. Already we have our constant 5 divided by 4 multiplied by the natural log of the absolute value of 2x squared plus 4x plus 3, right? So now let me take the second one and integrate it as well. We can factor out 2 from our denominator. So this is equal to 4 multiplied by the integral of 1 divided by 2 outside. Inside we have x squared plus 2x, right? Then plus 3 divided by 2 dx. And this 2 can come outside and it will divide 4. We have 2. So this is equal to 2 multiplied by the integral of 1 divided by x squared plus 2x plus 1, right? Plus 1 divided by 2. They're all the same thing because 1 plus 1 divided by 2 is the same thing as 3 divided by 2 dx. The first 3 times can be factorized, right? This is equal to 2 multiplied by the integral of 1 divided by x plus 1 all squared, right? That is the first 3 times. Then we have plus 1 divided by 2, which I can write as the square root of 1 divided by 2 all squared. For a reason, I'm going to show you why. So let me show you why I wrote 1 divided by 2 as the square root of 1 divided by 2 all squared. Remember that if you have the integral of 1 divided by x squared plus a squared, this is equal to, okay, with respect to x, right? This is equal to 1 divided by a, right? Multiplied by arctangent or tan inverse of what? X divided by a, then plus the constant of integration. So let us apply the same thing in integrating this function. So it will be equal to 2, which we have as constant. Then it will multiply the whole of this. What is 1 divided by a? It will be 1 divided by, this is our a, right? Because we have a squared. So it will be 1 divided by root of 1 divided by 2, right? Multiplied by arctangent, let me say arctan of what? X divided by a. But this time around we have x plus 1 as x. We have x plus 1 divided by a, and a is what? Square root of 1 divided by 2. We don't need to add plus c because we have the other part. But I can simplify this. We can introduce this 2 inside. This will become 2 divided by the square root of 1 divided by 2 multiplied by tan inverse of what? X plus 1 divided by the square root of 1 divided by 2, right? So this is what we have to the other integral, but we have our first solution. Therefore, we are going to take the first solution, which is this one, and subtract the second one. So let me just copy that. So this is the first part. We are going to subtract the second part. I'm just going to copy that as well. And hence, this is the solution to that problem. And don't forget to add the constant of integration, for which this constant belongs to the set of real numbers. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.